Hi, this article is related to parametric sensitivity analysis of permanent magnet synchronous motor for the minimizing of electromagnetic vibrations in MATLAB. So in this article, basically, I have just written the abstract of the parametric sensitivity analysis, which plays a crucial role in understanding of how design variables impact the electromagnetic vibration behavior of permanent magnet synchronous motors. And in the MATLAB framework, we have just integrated the electromagnetic torque modeling vibration responses estimation with the statistical sensitivity techniques to identify the influential parameters. Okay, so in the permanent magnet synchronous motors vibration for the vehicle applications, we have used to identify its complete regression coefficients, its partial rank correlation coefficients, and its the complete radial forces with its torque ripple with its harmonic forces in the MATLAB to minimize the torque ripple and for the better applications uh, for the better uh, uh, synchronous motors applications, and which will in this simulation we are just removing the noise in the permanent magnet synchronous motor in terms of vibration noise, in terms of electromagnetic vibration, in terms of noisy vibrations. So due to this article, we have just reduced its vibration without requiring the costly finite element simulation. It means that the cost is the same. We are not going to increase the cost for the permanent synchronous motor, but we are just going to increase its efficiency and remove its vibration and noise. Okay. So here is the keywords with the introduction in which I have just written how the permanent synchronous motor, permanent magnet synchronous motors work, and how the vibration, electromagnetic vibration and noise and the permanent magnet synchronous motors come, and how the field circuit coupling and how it's the structure is resonance interactions. Okay, so here is just a picture of permanent magnet synchronous motor, and where electromagnetic combinations are headed in placed inside the rotor. Okay. Yes, background and motivation is that we have just using to the synchronous motors are used in electric vehicles, aerospace systems. So that's why we need highly efficient model with the excellent controllability. So that's why it's some motivation and importance. It means that we need to control its sensitivity. We need to provide us the efficient model in terms of sensitivity analysis, in terms of noise-free and noise-free electric motors. Okay, so yes, objective of the study. Objective is same like how we can just minimize the torque ripple, how we can just minimize the radial force harmonics from various parameters combination, and we are just applying the Latin hypercube sampling and a wide design space which explored efficiently, and we will include the SRC and PRCC are then computed to evaluate each parameter's influence on vibration. So here is the role of electromagnetic forces in permanent magnet synchronous motors. So basically, these forces arises in interaction of stator magnetic field and rotor permanent magnets, slotting effects, and the magnetomotive forces. So these forces are just implemented and providing the disturbance on air gap flux density becomes uneven, and the resulting radial forces fluctuate and create mechanical excitation. So we need to overcome these forces and provide the stability in terms of mechanical and electrical permanent magnet synchronous motors. Okay. So need for multi-parameter statistical exploration means we are using the Latin hypercube sampling methodology, which is particularly effective for this purpose, and we are using the uniform coverage of the design space. Okay, by generating the diverse parameter combinations, LHS provide us both linear and non-linear behaviors. Okay, so here is a practical relevance for industrial application. Practical relevance is that we are just connecting these permanent synchronous motors with the robotics, with the smooth motor operations, with the higher precision and stability. In the aerospace applications, we are using these motors in drones. We are using in airspace models, and we are using these efficiency-based permanent magnet synchronous motors for the causing of torque reduction and the efficiency of improvement in different airplane models. Okay. So here is the problem statement. Problem statement is the same like due to torque and its mechanical instability, it provides a noise, it provides us the mechanical instability, and it also provide a structural reliability, acoustic comfort, and overall the drive performance. So mathematical approach is this. We are using the mathematical approach for the stator slot, for the rotor, for the electromagnetic torque. So these are the equations used in that case with all the coefficients, and the methodology is placed here. These are the design parameters used in it, and these are MATLAB simulations, which is basically provide us the MATLAB simulation parameters with its explanation how torque, ripple, and radial forces are based on electromagnetic theory, how magnetic geometry and the slotted effects are uh, present in this section. So here is the MATLAB simulation of results in terms of vibration and root mean square with the counts. Okay, and next one is basically the standardized regression coefficients according to the router, slot, stator, slaughter, pole pairs in the slot opening, skew angle, magnetic ratio, and the magnetic torque, air gap as well. Okay, this is a partial rank correlation coefficient. This is the same for all the rotor, stator, and all the types of the air gap. Okay, then this figure contains a scatter of rotor or m versus the vibration. Okay, and this figure provides us the parameter correlation heat map according to the permanent magnet synchronous motors design parameters. So different thermal heat map occurs in terms of different heat parameters. Okay, these are the parameters, and these are the yes, both sides are parameters and the heat maps accordingly. Okay, so here is a scatter matrix for the top four influential parameters. This basically presents the pole pairs and the in terms of influential permanent magnet synchronous parameters. Okay, so here is the results with discussion in terms of sensitivity analysis results, SRC and PRCC, and here are the conclusion with the references as well. Let me show you the output in terms of MATLAB model. We just need to open here, yes. Okay. These are the function files. We don't need to run this function file because the function files cannot be able to run it these function files used in the main files in this main file. Okay, so let me just run this function files with clear R package. So PMSM sensitive analysis basically I have defined the complete parameters for the vibration reduction for the LHS sampling, integration of parameters as well as other parameters accordingly. Okay. Just a second. What is happening in it? Okay, okay, okay. Let me run step by step. Parametric defines in terms of here is the MATLAB's models which runs the output of equations in terms of distribution of vibration matrix, in terms of standard regression, coefficients, partial rank correlation, scatter rotor, this is and the scatter matrix stock for influential. Okay, and these are the output of parameters like running 100, 800 model evaluations, air gap, magnetic with the skew angle, and all the parameters of permanent magnet synchronous motor. Okay, if you need to ask anything, you just ask me. Okay, these are the function files, and these are the main files to run it. Okay, you just need to run that file, so you will get the output results. Okay.